Assalamualaikum girls. I am Shamsunisa from Royal Degree College, Chemistry Department. Today in third session, we will be dealing with experimental determination of magnetic susceptibility, GUOY method, electronic spectra of metal complexes, color of transition metal AQUA complexes, DD transition, detection of complex formation, magnetic susceptibility, thermodynamic stability of transition metal complexes, kinetic stability of transition metal complexes, and stability of metal complexes. Now we'll see first experimental determination of magnetic susceptibility, that is GUOY's method. So the magnetic susceptibility of substances can be determined by GUOY balance method. Generally, a paramagnetic substance shows greater weight than its net weight, where in the magnetic field or in the GUOY balance due to attraction. And diamagnetic substances show less weight than its net weight due to repulsion. Now we'll see the procedure. In this method, finely powdered sample or solution is taken in a Pyrex glass tube. It is also termed as GUOY tube with uniform cross section of 2 to 10 mm and height 5 to 10 mm. A scratch mark is made at a fixed height and the tube is placed in a moisture and dust free compartment. Then a sample is weighted without the magnetic field and then with the magnetic field. The change in the weight. Now we'll see the change in the weight, that is delta W, is found. Before filling the sample in the tube, the weight of empty GUOY tube without magnetic field and with magnetic field are taken. The difference in the weight of the tube, delta, is calculated. So here now we are seeing the calculation of magnetic susceptibility. It is indicated with psi base m, and magnetic moment efficiency of magnetic moment, that is mu efficiency. So magnetic susceptibility psi base m, it is given by this equation, that is psi base m, it is equal to alpha plus beta into delta W plus delta into capital M divided by W, where W is the weight of sample, capital M is molecular weight of the sample, alpha is equal to 0.029, it is a constant value, into specimen value of the tube. Beta is calibration constant. Next, magnetic moment, it is given by this particular equation. Efficiency of magnetic moment, that is mu efficiency, it is equal to 2.84 under root psi base m into T, capital T. So here the capital T is nothing but the absolute temperature. Now we are talking about electronic spectra of metal complexes, color of transition metal AQUA complexes, DD transition. So in this, most metal ions and complexes of transition metals absorb radiation. Where they are going to absorb the radiation? In the visible part of the spectrum. And so they are colored. Example here is electronic absorption spectrum of this particular complex ion. That is square bracket Ti, H2O taken 6 times, square bracket closed to the power plus 3. Here the central metal atom is titanium. Atomic number of titanium is 22. If you are writing the outermost electronic configuration of titanium 3d2 4s2. Now when the titanium atom is losing the 3 electrons, it is converted to titanium ion, that is Ti plus 3 ion. Its outermost electronic configuration is 3d1 4s0. Means from the titanium, from 4s, 2 electrons are lost, and from 3d, 1 electron is lost. At that time, we are getting the electronic configuration of titanium ion, that is 3d1, 4s0. In presence of ligand, water. Here we are taking water as a ligand. So in presence of that will degenerate d orbitals of titanium ion split into two sets. One is T2G and another set is EG. Unpaired electrons of titanium ion enters into T2G orbital. Why they are entering into the T2G orbital? Due to unpaired electron excitation. Unpaired electron excitation, because of that reason, the titanium ion unpaired electrons, they are entering into the T2G orbital. And a formation of complex will take place. That is the complex ion we are getting square bracket Pi H2O taken 6 times to the power plus 3. This complex ion is exhibiting the pink color. When complex ion absorbs visible light of 5000 degree angstrom, then the unpaired electron in T2G excites to EG orbital to give DD transition and exhibit pink color. So here the energy required for T2G1 EG0 to T2G0 EG1 means here the electron which is the unpaired electron which is present in T2G, it is getting excited, and after excitation that electron is going to EG set, EG. So DD transition is taking place. How much energy is required for this? 57 kilocalories per mole, which is available with wavelength that is nothing but lambda 506 nanometer radiation. Next is detection of complex formation. Here we are talking about how to detect the complex formation. The existence of complex ions in solution may be shown by various methods. So the basic principles of various methods are change in chemical properties, second one is solubility, third one is change in color, change in pH value, and the last one is conductivity measurement. So first of all, we'll see about change in chemical properties. When metal ion combines with ligands, what will happen? It forms a complex. And both of them means metal ion and as well as ligand. Both of them after the formation of complex, they will lose their property. Example here, when copper sulfate solution is treated with potassium cyanide, complex is formed. Which complex? This way, K2 square bracket Cu Cn taken 4 times. This complex is formed. So this complex does not respond to the reaction of either copper ion or cyanide ion. Next is solubility. Whenever sparingly soluble inorganic substance convert into a complex, at that time its solubility will increase. Example here we are seeing silver cyanide we are taking. Silver cyanide is sparingly soluble in water. Means sparingly means slightly soluble in water. When silver cyanide, it is treated with potassium cyanide. So complex is formed, which is completely soluble in water. What the complex is forming here, this particular complex, this complex is completely going to soluble in water. Then change in color. Change in color reveals formation of complex. Example, addition of ammonia to this particular complex ion. Our complex ion is Cu H2O taken 4 times to the power plus 2. In this complex ion, we are adding ammonia. Produces a blue color due to the formation of more stable complex. This is a more stable complex ion formation is taking place. So because of that reason, it is changing the color and we are getting the color of this complex ion is blue color. See the reaction, what is happening here? as we are taking the aqua complex ion here with the copper, square bracket Cu H2O taken 4 times to the power plus 2. In that, as we are adding the 4 moles of ammonia, water molecule from this complex ion is substituted with ammonia. So we are getting the complex, blue color complex like this, square bracket Cu NH3 taken 4 times to the power plus 2. So the 4 water molecules are coming out from that complex ion as a side product. Next is change in pH value. Ligands are weak acids or weak bases. Acidic protons are replaced by metal ion during the formation of complex ion. Thus, what will happen? Increases the concentration of H plus ion in solution. Hence, pH value consequently decreases. It indicates the pH value, what it is indicating? It indicates the extent of complex formation. Now, conductivity measurement. Strong complexes may be recognized by electrical conductivity of solution of their salts. Complex formation decreases number of ions. Hence, molar conductivity also decreases. Example we are seeing here, chromic chloride should give 4 ions, but it gives 2 ions. Why it is giving the 2 ions? Due to the formation of this complex, that is square bracket Cr, H2O taken 4 times, Cl2 square bracket closed, Cl. Because of the formation of this complex, chromic chloride, instead of giving 4 ions, it will give the 2 ions. Thus, conductivity decreases. Next one is magnetic susceptibility. What is this? This we will see. Susceptibility indicates whether material is attracted or repelled out of magnetic field. If you are creating a magnetic field, a material which is placed in the magnetic field, whether it is attracted towards the magnetic field or it is getting repelled from the magnetic field, it is indicated with the help of susceptibility. So the qualitative measure of susceptibility, that is magnetic susceptibility, it will provide insight into the structure of material, which in turn provides insight of bonding and energy level inside the material, which type of bonding is going to be formed, which type of energy levels will be there, it is indicated. Then magnetic susceptibility can be calculated by which method? Can be calculated by GUOY's method. Next we will see about thermodynamic stability of transition metal complexes. Change in energy going from reactant to product. When the reactant it is converting into the product, the change in energy will take place. Is known as, that is only known as thermodynamic stability. It is given by this particular equation, that is delta G, it is equal to delta H minus T delta S. It is equal to minus RT log K. Delta H is what? Delta H is enthalpy. Delta S is entropy. Delta G is Gibbs energy, change in Gibbs energy we can say. Then the K is equilibrium constant for the reaction. Now next, kinetic stability of transition metal complexes. This we will see. It refers to reactivity, generally ligand substitution it is dealing with. Based on kinetic stability, complexes are of 2 types. One type of complex is called labile complex, which is also known as non-inert complex. Another one is inert complex. Next is stability of metal complexes, where we see most of the complex ions are highly stable. In aqueous solution, most of them dissociate to slight extent to establish an equilibrium between central ion and ligand. Here we'll see one example. Here we are taking this particular. So as we are taking here square bracket Ag NH3 taken twice, square bracket closed plus this complex ion we are taking. It will dissociate to give Ag plus ion plus 2NH3, 2 moles of ammonia. Thus, equilibrium constant, that is K, is given by this equation. Equilibrium constant for this above reaction. So the K, it is equal to molar concentration of the products divided by molar concentration of the reactants. So we are writing here square bracket Ag plus, that is known as molar concentration of Ag plus, molar concentration of ammonia NH3. 2 moles of ammonia is there now, so that's why we are writing to the power 2. Then divided by molar concentration of AgNH3 taken twice, square bracket close plus. So the equilibrium constant K is known as dissociation constant, that is indicated with R in stability constant. So stability constant is inversely proportional to dissociation constant. Thus, greater stability constant of a complex ion, lesser dissociation constant. So more will be its stability. If suppose lesser stability constant of a complex ion, greater dissociation constant, and lesser will be its stability. Thank you girls for listening my lecture.